Okay, so I'm introducing our offboard gas connection assembly. This is maker model or brand of rebreather agnostic, and the principles here can really be applied to any unit. So the main principle here is that one single gas supplies all the functional components of the rebreather on the diluent side. So we have one supply line. This is from the diluent of choice. It doesn't matter where this is positioned on your rebreather. It could be hard mounted on your back or somewhere else, or it could be an off-board cylinder or some other supply. But we have one diluent supply connected to the rebreather at a time. And then allowing that distribution into the unit is a CEJN or Sequest style high flow nipple through a non-return valve. That piece is important in the event your supply whip bursts or is accidentally disconnected. After the non-return valve, we have a splitter, and then from the splitter we have two gas paths. One is to the ADV, and the ADV shutoff is at the block and accessible with our fingertips. We can feather the ADV in the event it's free-flowing, or we feel the need to shut it down if it's being too aggressive in its function for the time being. So we can feather that ADV right there at the block. And that's the same slider we use in other assemblies, where you slide towards the ADV if you're on, we see a green ring, and away from the ADV for off, we see a red ring. The second line would go to a BOV or a standalone bailout regulator, which is the case presented here. If this line were to be shut down, and the slider could be right at the regulator, that's a common position for it, we have to remember that if both that regulator and the ADV were shut off, it's possible to have a volume of gas trapped with nowhere to go. So that's not the ideal solution to have two shutoffs. But in reality, it'd be very unlikely to have both devices shut off simultaneously. So if we had a shutoff here at the ADV, that's okay, and then a shutoff at the BOV or regulator, that's probably not detrimental to the design of the system. But in its simplest form, this is a great way to introduce a single diluent gas appropriate for the given depth into the rebreather, and then start supplying any number of peripheral devices. So from here, I'm going to do another video and expand on this to show the additional integration of a manual addition valve off of these same principles, with one gas supplied to the diluent side of the rebreather at a time.